I'm really excited to share this panel with some industry veterans talking about the emerging space of virtual humans. It's a technology space that really is the sum of its parts of a lot of different technologies that we've been talking about at Dreamland today. I'd like to introduce Kaspar Tiri from Wolf 3D, who's doing some incredible things with avatar technology and the future of digital identity.
Thank you, Raymond. Yeah, so my name is Kaspar. I'm the co-founder of a company called Wolf 3D, and we're building identity layer for virtual experiences where people can create 3D avatars of themselves based on a selfie and use them in various applications, from games to virtual meetings to conferences, virtual concerts, and many more other applications.
Yeah, and a legend of the industry, Greg Passmore, who's been doing things with sensor technologies, volumetric capture, all the different XR technologies. Greg, why don't you tell us a little bit about yourself?
Sure. So my background is predominantly in the research area, and we have a research lab that we put together that tests all kinds of sensors. We do everything from focal stacking to LiDAR to photogrammetry to really just bizarre kinds of sensors, and merging them all together into kind of a fused format. And then we predominantly work in point clouds. And so we're not so much, unlike Kaspar and probably Raymond, we're not so much on the deployment side. We're really on kind of the lab coat side, trying to figure out what are the best options for being able to produce photorealism.
Yeah, and I think that's going to be an interesting topic today in regards to how real, what is the definition of a virtual human? I guess first also, my name is Raymond Moscow. I've been in the XR industry for a long time. I was an early Oculus employee, and most recently my startup Hypersense was just acquired by Epic Games, and I'm looking forward to seeing kind of what comes of our technology there. But I mean, moving forward, let's talk about the technologies that are associated with virtual humans. Greg, you talked about volumetric capture, you talked about point clouds. Kaspar, I know that you're using a lot of, Wolf 3D is using a lot of AI kind of in the back end. Let's talk about some of these technologies and how they're being leveraged in the virtual human space.
Yeah, and I can jump in and give maybe the wide context, and then maybe Kaspar, you can talk about how to actually practically use it, right? I started working on virtual humans back with a movie that probably nobody remembers called Looker, back in the 80s. And at that point, what they were doing was they were drawing little lines on people and basically doing measurements, right? It was extremely crude and time consuming. Like to digitize Susan Day was a huge project. And then, we've sort of watched it evolve over time, and there were some really big moments, where we thought that, virtual avatars were, this is their moment. And of course, it never really came, right? It was always in kind of starts and such. But it's accelerated a lot recently, and it seems like, there are kind of two parts of it, right? There's the part where you're trying to do the capture, and then there's the part where you're trying to basically do the restoration and enhancement. And the restoration and enhancement lately has been really focused on the use of AI and machine learning, which is certainly helpful. And the capture part is really where we've done a lot of our focus. And so there are a wide variety of techniques out there, everything from getting your ruler out and measuring people, which is not as uncommon as you might imagine, to using multi-million-dollar stages. And it seems like no matter what technique you use, everybody runs and they all wind up in very similar spots, right? You get something that looks really great, and then they move, or then they speak, or then you see their eyes up close. And of course, so those are some of the remaining challenges. And so we focus on point clouds predominantly, so that we can do fuzzy phenomenon like hair, or any number of things that don't really have hard boundaries, which humans are really good at. Clothing, for example, sheer clothing, those kinds of things. And so our lab is set up so that we can test everything under the sun. And then every time something new comes out, we acquire it, we test it as well. And then we kind of put it out there in the big Venn diagram and try to figure out what are some of the better ways to do that acquisition. And then we hopefully hand off that information or knowledge to people like Kaspar and Raymond so that they're capable of actually doing something useful with it.
Yep. So for us, it's always been very important to understand, like, how do we capture people at scale, but also what the end user values in their avatar. So we started our journey in 2014, and the very first approach to capturing people were like our first hypothesis was, of course, that it's a virtual world. People want to be real versions of themselves, like one-to-one version of themselves. So to test this, we built the photogrammetry-based scanning rigs, 100 cameras in a rig, and we set it up in shopping malls. We get people, everyday people got into scanning rig, we scanned them and really started to learn what those people value in the avatars once we had captured them. Something we really quickly learned was, people really don't want to be one-on-one versions of themselves. We relatively quickly understood that people are very self-conscious about their bodies. The number one question we got asked was, can you take my face and put it on a game character or Superman's body or something like that? We're talking about virtual worlds, so people want to, they want to express their imagination and fantasies. So this was something we learned pretty early on, that, in order for us to create something that people value, we shouldn't capture everything realistically, or at least render it realistically to them. So the first product we scrapped relatively quickly, but that kind of gave us the learning that we should build something that really captures your identity, the way you look, but allows you to express some level of imagination there as well. And we turned it into a fully automatic scanner booth, which worked like photo booths. So we really have like a hardware background that has transitioned into software in the later phase in the company. But what's important for us during this transition was those scanner booths that we had built. We managed to build a network of them around the world in different high foot traffic locations, which means that we ended up with a very high, very large database of face scans, which is really, helpful for understanding how, certain human faces are being, created and what makes them unique. And that kind of led us into transition into software that allowed us to use the database we had captured to build a deep learning solution. And even then, we were really focused on capturing realistic humans, but giving them, more, variety on their bodies. But that still didn't work because we wanted to work with different games, and that, that kind of forced us to really understand that how can we take the realistic characters that we're now capturing based on a single image, and how can we transform them into all of the styles, that are out there, from the Minecraft looking character to some AAA character that looks very realistic. So we had to understand what makes people look like they are, or what makes you essentially. And it's not that much of a math problem or algorithm problem. It's more rather like, how do you combine art together with the data that you're capturing, and how do you generate it all together that the end user actually likes it, and they feel like, oh, that's me, and it has like this beautification layer on top. Because what we've learned throughout the years is people really want their avatars to be presented as slightly beautified versions of themselves. And I guess that really boils down to the way we've been living in social media, and our social media profiles are augmented versions of ourselves. So that's where the asks also come from. So this has been a challenge that we've been working on for a while already, and it's a very hard problem to solve. And that's only on the capture side. Craig mentioned a little bit animations there as well. So now you add the animations on top of this and make sure that the avatars don't look uncanny. And that's another set of problems that I think, Raymond, you have more experience with because Hypersense was a company who made avatars alive, essentially.
Yeah, definitely. You know, like Kaspar, I think you touch a very important element of the uncanny valley as it relates to avatars. You know, Greg, like with what you're doing with a lot of volumetric scanning and things like that, you're trying to create these hyper real, you know, one-to-one creations of avatars. Whereas, you know, I feel like as we've tried to present more and more realistic avatars, we're realizing that it's really hard to drive a realistic avatar. You know, compared to say something that is built, you know, from a matter of blend shapes that then allows you to be able to move in real time and kind of understand all the different transformations that are going to happen in the face, compared to, you know, what is necessarily happening with the actual landscape of the geometry that the face actually holds. You know, at Hypersense, we explored that a lot. You know, we are always getting these requests for how can we drive super hyper realistic characters, and we realized that, you know, when you look at say a character like, you know, Thanos, which is very famous, you know, in the movie Avengers, that has, you know, probably 300 or 400 blend shapes associated with it. You know, Greg, you touched on the size of these avatars that are being built. You know, like that just doesn't scale very well as it relates to both the walled gardens of whatever application that you're building, that you're going to use these assets, but then the idea of, you know, being able to open up these assets to be able to be used in different places. You know, if this is like a 50 gigabyte, you know, 1 terabyte, you know, like size file, like there's no way that we're going to be able to move those around so that people are going to have these customized experiences. And I think that also brings kind of the interesting question about the use cases for virtual beings, right? You know, like there's a lot of technology associated. You know, we can go in deep in regards to AI and volumetric capture and how game engines are being leveraged, kind of being the pass-through tool to make all these assets be able to be usable everywhere. But I mean, how are these tools being used? You know, Greg, how have you seen you know, the type of captures that you're using? You know, what are some of the use cases that you're finding being leveraged?
Right. I mean, one of the assumptions I think that's often made is that these characters have to operate in real time, right? And you're right, the databases are huge. I mean, our average database is probably a terabyte for a character, and that's not something you want to move around in like the Unity engine. But there's an awful lot of use cases where we're doing, let's say, medical simulations, or we're doing, you know, behavioral studies, and we're interested in trying to understand, you know, how slight, subtle movements can be analyzed. And so the whole simulation world really, I think, uses non-real-time photorealistic avatars or humans as a method of being able to better understand us, you know, and the way we work. And so, I mean, so our focus, you know, so a lot of this depends upon the time scale that you're looking at. So when you're in implementation mode, the time scale is, well, we have to get a product out, and the product has to be out, you know, next month or end of the year or next year. And when we're doing research, we're primarily concerned with, all right, so where are we going to be in 5 years, 10 years, right? And so the problems that are facing you in the implementation and deployment process are very different than the problems that we're trying to address, which is this solvable? And if it is solvable, is it solvable in our lifetimes? And so a lot of the things that we work on, you know, you would look at it and you'd be like, well, that's completely impractical. Why in the world would you ever want to do that? And yet simultaneously, what we find are little tidbits and little lessons out of all of it that can eventually feed then into more real-time applications. And we do have a real-time viewer. We can display a terabyte human and move them around and all those kinds of things at a 1 terabyte point cloud. But it's not the kind of thing that you would put on a, you know, a gaming computer. I mean, our standard computer that we use here is like 4 Quadro P6000s all running in SLI mode. And, you know, I don't know, what is that? That's, you know, it's an $18,000 array of equipment. And so, but it's useful in high-end Hollywood stuff where money is not so much an issue. It's useful in high-end military stuff where money is certainly not an issue. And it's, you know, occasionally, but not so useful in the gaming area. And then in non-real-time simulations for medicine. And, you know, we also do, one of the things that we're very focused on is understanding hyperspectral imaging. So we're doing a lot of work in the ultraviolet spectrum or in, you know, far IR or even in RF frequencies. So when we capture a human, we're not only looking at what is their visual reflectivity, and transmissivity and those kinds of things. We're also looking at it across a really wide spectrum so that, if we want to simulate humans standing in a room and we're doing RF backscatter calculations through a brick wall to identify victims in a collapse after an earthquake, we can do those simulations because we have that data.
Wow. And Kaspar, you're almost on the other side of the spectrum, right? Like you're, using your technology to convert a single image into a 3D avatar that can be utilized kind of readily, right?
Yeah, that's correct. When we think about our use cases, we kind of like very simply put it into two categories. It's either like consumer facing experiences that you can, scale very large, and there's others like one-off production that require high quality. So we're more on the consumer side scale spectrum of things, and people really come to us, with very different from very different industries, from medical industries like Greg mentioned, from simulations. How can you kind of like have a bunch of doctors in the same room for a lecture? Everybody needs their identity, so we can help in training simulations or for meeting applications or concerts or anything where you need to create an avatar very quickly in a couple of seconds and have it in your environment in runtime. That's what we are really good at, and the use cases vary from police that are using it for crime scene recreations to just like social consumer apps and games, and everything in the middle. That's what I think is really interesting about avatars. There's no limit to use cases. You can, and that's a problem for us as a company as well, because you can go everywhere. You can go to gaming, you can go to entertainment, social apps, or anything above, and you'll find a use case for avatars. That's kind of the exciting area for us as well, because we can see how large this thing can grow, because there's so much utility for avatars on the consumer level, and also on the production level, like Craig mentioned, like large Hollywood movie studios that are using similar technology to create very high quality realistic humans that are already quite difficult to differentiate from a real human.
Yeah, it's interesting because I feel like the virtual beings or virtual human space is really like the smartphone sector. Like in the next 5 years, people are going to look back and they're going to forget this time where we didn't have, like, essentially we're not dealing, interacting with AI powered, clients, or we're not dealing with having kind of our own virtual twin that is somehow interacting in the world, and I think that's something that's really interesting to kind of look out forward in the future, with, talks of the, Facebook is building a metaverse. I'm a firm believer that kind of what Epic is doing with Fortnite is really kind of its own version of a metaverse. Roblox is a great example of it as well. Like we're going to have these virtual identities in all these different spaces. Like how do you think that the kind of concept of virtual beings are going to connect into that?
I think that's
I think it's a very good question. The way we think about this is that there will be different kinds of metaverses. There will be Fortnite, there will be Roblox, Minecraft, and a bunch of others that are up and coming. One thing that's always constant is your avatar, and I believe people will in the future have multiple avatars. Like this is my business avatar, this is my social avatar, this is my this is my avatar as an IP. Maybe maybe I want to sell it as for movies, for example. I think people will have different avatars for different use cases. There will be different, metaverses, but our bet is that as the avatar is consistent in throughout all of those experiences, that creates a truly immersive experience when you can hop from one experience to another. That's something what we do with Ready Player Me today. We have multiple different applications where with a single click you can use your avatar in a business meeting, and then after you finish the business meeting, you click log in with Ready Player Me and you're in a virtual concert, and maybe you're wearing different outfit. Like that's for us, that that's the truly immersive metaverse where you can see some consistency throughout the experience itself.
It's kind of an interesting issue too, because you're talking about, having these various avatars, and in medicine, one of the huge problems, a lot of people believe that the majority of fatalities that occur in hospitals occur because teams miscommunicate. It's not because you're too sick, it's because people can't communicate effectively. And the way that we as humans communicate with each other is through a lot of metadata, right? It's not just the words that we say, but it's the subtlety of our facial expressions and trust issues and those kinds of things. And I wonder if the error rate of communication will increase with the use of avatars, which are not perfect. And as a result, then the error rate of the end results wind up increasing.
Yeah, Greg, I think about that a lot because I think of like the impact of virtual humans as it relates to things like, medical and, training as well as like education, and while I think it's exciting, the idea that I can sit in a physics class and, Albert Einstein could be my teacher and he can teach me everything that I want to know about the topic. But at the same time, yeah, I wonder about the kind of the finer sort of nuance of human interaction. And does that get lost as a result of, both human powered virtual beings, as well as AI powered virtual beings, that when you have these characters that are essentially just, very sophisticated chatbots that are powered by very complicated databases of understandings and essentially reactions to what you, the user, are doing, compared to say like having an actual person who just essentially putting on a virtual being and interacting with you directly.
And I can give you a very specific case because that always seems to help. One of the simulations that we've been involved in is infant cardiac arrest, right? So you have an infant, it undergoes a heart attack, and you have a very, very short period of time under which to react and do anything. Otherwise, the baby dies. And so one of the protocols that's been installed is something called CUS, which is about concern, uncertainty, and safety. And so a low-level nurse has the right to question the doctor about whether or not something that's being done is correct. And if the doctor doesn't respond, they can go up a level above the doctor's head. And so, in talking to nurses and understanding, how do you identify whether you're concerned? How do you identify whether there are safety issues? They don't ever really talk about very specific motions or very specific words. They talk about expressions in a sense of that there's some sort of safety issue. And so, I don't know, just an interesting area where as we get into avatars, there's going to be that period of time between when they are perfect and they're imperfect. And then, we may wind up getting into virtual arguments with people about things that, in fact, aren't arguments at all, right? But we just misunderstand each other. That's all.
Yeah, I mean, Greg, do you think though, like with kind of the improvements in computer vision though, like that these are some problems that technology can solve? We talking about expressions that eventually, a camera on a patient might be able to recognize a specific facial expression or a specific body motion, and then, be able to flag that and possibly escalate it up accordingly or something like that?
Yeah, although you're not normally looking at the patient, you're normally looking at the doctor and the other nurses that are there, right? It's like, why are you doing that exactly? What are you thinking? Why did you not foam up, before you came into the, the OR? So, but yeah, I mean, clearly avatars will at some point become perfect, right? They will become unrecognizable from us. They'll be the faces of silicon intelligence. I mean, that will happen. Maybe not immediately, but it will happen. And and that's a whole nother crazy world, right? But at the moment, the danger, I think, is this middle space between, your spouse is from another country and English isn't their first language. And so you get into arguments over things that have nothing to do with anything except that you misunderstood each other. And I think that happens through facial expression inaccuracies in avatars as well. And we might see conflict or misplaced affection for avatars where, in fact, the communication process is damaged because the meta messaging system isn't correctly working. I don't know. It's a long answer to a short question, but I mean,
Yeah, I mean, but I think you bring up a really interesting point, Greg, about like kind of the dark side of virtual beings, right? You know, like right now we're just finishing up an election. You know, there was a lot of fear about like kind of the impact of things like deep fakes and, you know, virtual influencers impacting these sort of things. What are your concerns? You know, both of you, Kaspar, you know, I think you're probably going to be, you know, what you're doing is probably most readily accessible to folks to be able to create virtual influencers, as well as like, you know, characters that could possibly slander professionals or things like that. You know, what are your thoughts on the kind of the dark side of what's coming with virtual beings?
Yeah, I mean, from our side, what we are trying to create is like real identity-based experiences, because what we've seen, you know, historically on the internet, you know, anonymity usually brings the worst of humanity. If we think about like experiences where anonymity is very high, there's usually more like cyberbullying and stuff like that. So what we're hoping to achieve with what we do is by building real identity-based experiences, we can reduce that. So that's something that we really hope that we can bring into this industry or different industries where avatars are being adopted. There's definitely risks, like you mentioned, like people trying to embody someone else's avatar and, you know, pretend that they are that specific person. Those are definitely, there are definitely various risks involved in this, and we don't have like very concrete answers to how to solve them. I guess we need to kind of live and learn and adapt accordingly once you know, once we move forward and learn from the experiences we've had.
Yeah, definitely. You know, I think I think that eventually there will be these scandals that occur where some famous, you know, VTuber or virtual influencers assets get stolen, and then there's all kinds of, you know, hate speak and, you know, fake brand campaigns that are associated with this character and things like that. But I mean, I think it's exciting, you know, like I was talking with someone who's kind of in the virtual talent space, and, you know, the benefit they said is that these characters, you know, like they never go to rehab, they never miss a flight, you know, they're always on time. They can you know, if you need them to do the dialogue again, they can do it, you know, indefinitely, which kind of taps into the world of virtual production, which is something that I think is being very excitingly impacted by virtual humans. You know, if anything, it's probably one of the kind of catalysts of this technology. You know, I know at Hypersense, you know, the founders of that company came from ILM, came from kind of virtual, you know, this idea of digital VFX and virtual production. And, you know, like that's where a lot of this like motion capture technology is coming from, at least from the computer vision standpoint. You know, Greg, I know you've dabbled in the entertainment space. You know, what are some of the other technologies that, you know, in your experience, you think need to start increasing their quality in order to kind of keep up with the pace of AI and computer vision?
Voice, right? Voice is one of a really big issue. It's like we can generate, or we can certainly capture really great motion, and we can generate really great imagery, but it's still really hard to manage the appropriate inflections and tones and raspiness and things of voice. And so I think that's pretty tricky. And some people in the industry feel like, oh, that's really easy. It's really a one-dimensional problem. But it turns out that we convey so much metadata through our voices about how we feel and stress levels and those kinds of things. It's really tricky. And then there are other sort of subtle things that occur that we see in the sensor world. For example, you don't really notice it so much, but it turns out that blood flow, right, is visible in pallor. So the pallor is, you know, basically the color of your face. And so underneath our eyes and in our cheeks and across our nose, we tend to exhibit, or you tend to be able to see hemoglobin levels. And as people get excited, or as people get upset, or as people, you know, change their emotions, we start seeing changes in facial colors, and we see very specific patterns, like the pattern across the nose, that are, we don't really register consciously, but we clearly react to unconsciously. And so there's just a lot of these subtleties of well beyond, let's make a, you know, let's capture a human and let's replicate them, where we are communicating through, you know, that guy who has that little vessel on his head that he gets mad that it pokes out, but things which are much, much more subtle than that, such as the color of the lips, or wavering, or Parkinsonian kinds of motions when people get too excited. And I think that's a really interesting frontier where, my belief is that a substantial amount of communication occurs through these largely invisible mechanisms, and that when I talk about communication, it's not necessarily evil people. It could be two really well-intentioned people that are talking to each other and they miscommunicate, because there are so many missing dimensions of metadata on virtual humans today. And of course, everybody is heading towards solving that. But yeah, so that's where I think the frontier is in all of those things that are nearly invisible but not quite.
Yeah, I think of like what Apple's doing. They have a phone, they have a watch, they have ear pods now. Supposedly soon they're going to have a glasses wearable. And in all of these devices there are sensors, right? And all these sensors are driving kind of a core intelligence that's understanding what you were doing as a person. And I think it's interesting to think that perhaps through wearables we'll be able to kind of tap into kind of a social network of bodily emotions.
Right.
So what comes next? I think that we're at this very interesting phase with virtual humans. We're now at a point that we're actually having panel discussions about it. I think we have virtual influencers, the Hatsune Mikus, the Michaelas of the world that are becoming kind of common names, being selling brand, selling objects, making generating revenue as a result of these digital entities. What comes next? Is this, just, are we waiting for kind of someone to turn on the metaverse and then we're all going to be living virtually as our virtual beings? Are we going to be, going into stores and interacting with, the virtual Colonel Sanders when we order our chicken when we go? What do you think are kind of the big milestones that are coming next for this technology?
I think virtual avatars are impacting each industry from different angles. If we think about virtual avatars, we can categorize them into different technologies, like body capture, face tracking, body tracking. We can build a huge list of things that a virtual avatar actually consists of. Greg mentioned voice, which is also very important. How do you translate like voice in real time into avatar animations? That's a big problem that a lot of companies are also solving today. So I think in the next couple of years, we'll see big impact that virtual beings or avatars are doing in different industries, like fashion today, where there's a big problem with where fashion companies are trying to produce less waste. So companies are building like body capture. They can easily help people to build like more personalized clothing. And you mentioned games where a lot of fashion companies are actually transforming into games where they can still give the feeling of wearing Gucci in a gaming experience, so the person who buys that experience to get the same feeling as they do in real life by wearing the same the jacket, for example. So I think different industries will be impacted by avatars differently, and those industries will be helping to build up those technologies, and eventually it will become it will all come together. We're still in relatively early phase with all of those technologies, including us. We feel like there's a long way for us to go. It's a big problem to solve. It's not very easy to fool a human brain when you try to replicate another person. So yeah, I think we'll see impact in different industries. We'll see each industry helping a certain technology in a virtual being space to evolve. And then eventually it will all come together into one or multiple different metaverses.
Yeah, and the the work areas that we're in at the moment, we're heavily focused on, I guess, what the medical industry would call reproductive health markers, right? So what is it that makes somebody appear healthy or unhealthy? Because that's something that virtual humans have the ability to recreate as well, frequently accidentally. It's like, gee, there's something wrong with this individual, right? And so at the moment, we've been focused on what are all the things that indicate mental health scoring when you look at someone else. And in that way, you can then create a character who has the appropriate medical stresses and health stresses and or maybe attractive, attributes that, and we're working really hard on the personality structure, that is the database that makes up the personality of an individual, including the degree of randomness of behavior. Like the Craig Reynolds is really brilliant math computer graphics guy from the days long gone. I mean, he came up with flocking, right? And flocking was kind of a big deal at the time. And one of the things that we're looking at now in our lab is we're really focused on how do we capture the personality coefficients of an individual and build that out into a structure and understand the variance and the things that cause those variances to be invoked in order to produce a realistic personality on an actor or a character. And so that mixed with this reproductive health factor, when combined together, I think makes up a dynamic live human being that is more real than the image in the voice alone.
Yeah, I think the future is bright for virtual beings. Like I said, I made the analogy of the smartphone earlier. Like, I think it's just going to be something that we're going to be in the next 5 years. We'll be interacting with it in a lot of places, and it will just continue to grow. Well, we're getting to the end of our time here. Kaspar, Greg, how do we get in touch with you if we'd like to get a hold of you after this talk?
For us, it's easy. I mean, just hop on. Probably the easiest way to reach us is through PassmoreVR.com, and you can see what we're doing. And you can see pictures of our lab there and what we're doing, and just contact us through a form there. And Kaspar?
Yeah, and for us, you can visit our website, readyplayer.me or wolf3d.io. Those are two different of our products. So you can write us from there and check out what we're doing.
And for you, Raymond?
And for me, you can find me on LinkedIn or on Twitter at Raymond Moscow. Kaspar, Greg, thanks for joining me this morning. I think that virtual humans is a very exciting topic, and I look forward to seeing. Hopefully, next year we can look back and see, kind of based on the conversation we had here, what has come to place.
Thank you for moderating.
Of course.
Thank you.
All right, back to you, and we'll see you next time.